And as people integrate automation and digitization into their daily life, whether it's a smart thermostat or, a self-driving capability in their car, they're really looking for this, I think, in their work life. And the companies that are prepared to address that are going to really be the winners.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And while you're there, you can share any interesting or innovative use of fluid power that you know of with our hashtag #OnlyFluidPowerCan. That is one of the ways that we actually source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on most of the other podcatching services. Wherever it is that you find us, subscribe and then give us a quick rating. Those ratings really do help more and more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guest is Justin Katz. Justin is a manager for product management of vacuum automation at Schmalz. Schmalz is a market leader in vacuum automation and ergonomic handling solutions. And Justin, in fact, will be a speaker at an upcoming quarterly conference that NFPA is hosting in collaboration with PMMI, the Packaging Machinery Manufacturers Institute, because that event is going to focus on pneumatic solutions for packaging machines. You can learn more about that event and how to attend it, as well as all of NFPA's upcoming conferences on our hub, nfpahub.com. But today we invited Justin into our forum to learn more about his presentation that he will give and about advancing vacuum technology in the digital factory of the future. So Justin, welcome to Fluid Power Forum.
Thank you, Eric. I appreciate you having me on today. Glad to be here.
I'm happy to have you on. I'm interested in learning much more about the topic today. I confess that I don't know a lot about vacuum technology or digital factories, so I'm anxious to be educated in that space. But before we dig into those details, hopefully you can tell our listeners a little bit more about yourself. I said you're a product manager at Schmalz. How did you find your way into that position?
Yeah, sure thing. So to give you a little background on my education, what drew me to Schmalz as a company and what I do today, I joined Schmalz back in 2010 with a bachelor's degree from mechanical engineering, from North Carolina State University here in Raleigh, North Carolina. I had a strong interest in the automotive industry at the time, but, being a mechanical guy, I knew there was such a broader application of my skills. And Schmalz, which is also here in Raleigh, was a small company at that time of about 15 people. And I knew I really wanted to join an organization where I can make a large impact in it. So I like the idea that Schmalz was really diversified in the markets it served, even beyond the automotive. I could still be a part of that automotive industry through Schmalz, but also gain a lot of experience and knowledge in those other industries.
If I can interrupt you there quick, Justin, I got to ask, I always ask our guests about, you went to North Carolina A&T, is that what you said?
North Carolina State University.
North Carolina State. And you got a degree in mechanical engineering there. How much fluid power were you exposed to as part of that program at North Carolina State?
It was the typical fluid mechanics and class, but and they got into some hydraulics and pneumatics at that state. But it was really, after I joined Schmalz that I started to really see the power behind specifically pneumatics as a manufacturing tool. Right. So that's really where I started to dig into it.
So it really wasn't a topic that resonated with you as you were a college student. It wasn't until you got into the industry that you started to understand the value of it.
That's right. Yeah.
Okay. I'm sorry I interrupted your story, but I'm always curious which schools around the country are teaching it and which aren't. Unfortunately, there's fewer that are and many that are not, at least to our satisfaction. But go on. Tell us more about about your experiences at Schmalz.
Sure. So I joined as a junior applications engineer and worked up my way up through the ranks, if you will, in terms of apps engineer, senior apps engineer. But being that Schmalz was a pretty small dynamic company, I had to wear a lot of different hats and was exposed to other opportunities in the organizations, which led me to interfacing with sales, quality control, operations. But where I've landed now is really managing our inside sales team and working with a really dynamic group of engineers in our local product management here in the U.S. And it's really in that product management role that allows me to help innovate our products, specifically, with vacuum, which definitely has a fluid power as a part of that. And then offer that insight from the U.S. market into our German headquarters. And then I also get to interface with our other 17 subsidiaries around the world. So it's just a really fun time to be able to work with really high profile customers and be a part of cutting edge automation.
It sounds like a very dynamic environment. If I heard you right, there were only 15 employees when you started there?
Yeah, about 15. Yeah. And now we're creeping up over 100 here
in the United States.
US.
Wow.
And quite a bit more globally.
And is it mostly factory automation applications that you're dealing with, or what other markets does Schmalz work in?
So Schmalz gets into a whole array of markets around here. So we definitely have our automation group where we're doing components, and we're doing the typical suction cups and vacuum generators and things like that. But we also have turnkey gripping systems, and then we also have clamping solutions for work holding, and then also ergonomic lifting solutions where you have an operator manually manipulating this. But in terms of markets, we're really getting into all kinds. We're getting into the automotive industry, the electronics sector. We're getting into battery production and foodstuffs and food and bev. So there's really just a really wide array of use for vacuum.
And I'm assuming, well, you said food and beverage, so packaging machines must be part of that product, since you're going to be featured at one of our conferences with them in a few weeks.
Absolutely. Yeah. Packaging is a huge industry for us, as well as the logistics industry. So really tying those two into it with really tailor-made solutions also for those industries.
And
absolutely.
Is it all pneumatics for the base of technology that you're using? I know that's becoming, as we'll talk about, digitized and electrified in a lot of ways, but you get into hydraulics at all, or is it just pneumatics?
It's really just pneumatics at this point. We do have a little bit of hydraulic in some of our manual solutions, depending on how heavy the load is with our manual lifters, but it's primarily pneumatics.
That's great. All right. Well, as I said, we want to talk about vacuum technology and the digital factory of the future. And I guess let's start on that digital factory side. It's a term that I think people hear, but I don't know that everyone has a common definition of what that means. So maybe we can start there. What is your definition of a digital factory? What is that?
So the digital factory is certainly going to be a little bit different to each company that approaches it. But, the digital factory is something that Schmalz as an organization has been looking at for quite some time. Actually, since the late 2000s. The factory of the future, as far as I understand it and what I'm seeing quite a bit, the factory of the future is going to be one that really thrives on intelligent devices that you're able to integrate quickly. You're constantly monitoring them, and that they even communicate with each other. And so coming back to the Schmalz side, that means for us state-of-the-art vacuum components that we can then interface into the environment through these intelligent interfaces. And these interfaces can be things like IO-Link, Ethernet, meaning Ethernet IP, Profinet, EtherCAT. All the different ways you can monitor and access data. And then we even get into things such as industrial ready wireless, things like near field communications or NFC. That digital factory is going to continually gather that data. It's going to bring it into some sort of computing environment. It's going to interpret that for energy and condition monitoring and make it available at your control panel, your HMI, or maybe even on the operator's smartphone and in the cloud.
Right.
It's this seamless monitoring of the whole process that becomes possible, and it allows you to do really great things like predictive maintenance, preventing downtime, and optimizing energy consumption.
So it sounds like a connected factory would be another way to describe that.
Yes. Yep.
So
Absolutely.
really leveraging, the connectivity of the machines and the applications that are going on those machines, monitoring that data and using it to make adjustments, it sounds like, in real time.
That's correct. Yep.
And how, like, what's your sense of the market? I'm going to imagine that there are still many factories that don't meet that definition. Would you agree with that?
There are. I mean, we're seeing different trends depending on the market. So you have, of course, where our headquarters is, the European market, where there seems to be a little bit of a higher adoption rate on some of these things. It could be due to labor costs and things like that. But we are seeing a really progressive marching towards the adoption of this technology.
So it sounds like it's a quickly evolving marketplace. What do you think is responsible for the speed of evolution in that environment?
Yeah, so industrial manufacturing is definitely evolving every day, and it's really being driven by the need to meet consumers' growing and ever-changing requests. We see this drive towards customization. Everybody wants things quickly delivered, in a variety of industries, and digitization and this concept of an industry 4.0, industry 4.0 being a buzzword where it's this fourth industrial revolution. Where you have machines talking to machines, as you mentioned earlier. These can be one of the methods that allows that to happen. The production of products can become highly flexible. So this is one way that they're evolving. You can have really productive and resource efficient processes. And then in addition, customization of the product, meaning, batches of one or a few, you can have these things start to happen in a high volume production environment.
Yeah.
So one of the examples is like the automotive industry. When we think about the automotive industry with all the different packages consumers can choose for their vehicles now, how do you manage that? Well, with that customization comes an increasing complexity of production, and digitization helps make that manageable.
You mentioned like consumer demand is really the highest level driver in all of this, that the demand for a wider diversity of products and packages and whatever it is that the machines are making, it sounds like. And that's really what's driving a lot of this?
Yeah, I think so. It's really going to be how consumers get what they want and when they want it, excuse me. So, your machinery and your adaptation of your tooling or your processes has to be able to move with that.
Right. Yeah, you can't take a whole shift to turn over the production process, right? You got to be able to switch to the new format as quickly as possible.
Absolutely. And, with autonomous production, you can even begin to see where some of the production processes might be able to organize themselves kind of on an ad hoc basis. So
right.
You're always going to have a lot of human intervention, but now the human side is really going to bring along their value add, and then more of the automated processes can do what they do best.
That's great. I appreciate all that background. This is a fluid power podcast, though, so let's start talking about fluid power. So, like, where do pneumatics and vacuum technology kind of fit in that transition that you're talking about?
So fluid power, and moreover the pneumatic side for us, has and it'll continue to play a key part in this. The digital factory will still have to produce products, and fluid power is a major means to help do this. Again, pneumatics, specifically in Schmalz's case, can easily be combined with digitization technologies like a vacuum or a pressure switch. And this helps to bridge that connection or bring those two together between fluid power and Industry 4.0.
Yeah. I mean, vacuum technology is kind of a niche area within pneumatics. It uses that compressed air in a slightly different way than your traditional pneumatic system. But why is that something specifically for us to be looking at in the years ahead?
So there's a lot of material handling methods out there, material handling, being picking and placing typically, but vacuum technology specifically offers a number of benefits that we've realized over the years, and it actually makes it one of the best methods. So for example, vacuum is gentler on a workpiece than, say, mechanical gripping. It's really interesting to think about the idea that there actually isn't a true mechanical gripping force when you're handling with vacuum. Rather, it's all the atmospheric pressure around it and pushing the vacuum area of your lifting component and the workpiece together. This is what's keeping them together. So it's really gentle handling. It's also offering really simple part control. So when we employ a vacuum switch to monitor this, we not only know that the part is present, but moreover, we know the quality or to what degree as to how well that part is gripped. This means we can start to understand and calculate how fast we can move with that part reliably. And this means we can really safely increase its throughput because we know how well or the quality of the grip.
Yeah, it's really a technology. It has a ton of versatility in it, as I understand it. I mean, it can be used to lift very heavy things, but it also can be used to move very delicate objects, right? I mean, it's sensitive. Is that just inherent in its nature, or how does it do those kinds of things?
So it's the fact that you have the atmospheric pressure over the entire area of the part or the effective area of the part. It means you can vary that. So vacuum at the end of the day, in terms of our force calculation, comes down to a very simple formula. It's your effective area, as we call it, the area that's experiencing the vacuum, and then your actual vacuum depth or your pressure differential. So by manipulating these two variables, which in essence sounds easy, it allows you to change how gently you handle something. So if we take a relatively low vacuum and put it over a very large area, we're having a very low pressure or, a very low force per area on the part. Mm-hmm. So this means you can handle it, even a delicate part, without damage.
As I said, it's versatile in that respect. As I listen to you describe that, Justin, that old canard that people talk about in sci-fi movies about when the spaceship depressurizes, whether the person is being blown out of the hatch or sucked out of the hatch, right? So, and that's just what occurred to me. So you're saying that it's not so much that the part is being sucked onto the vacuum implement. It's the atmospheric. You're creating the vacuum, and then it's the atmospheric pressure that's actually pushing and holding that part onto the vacuum appendage. Is that a fair way to describe this?
Yeah, that's absolutely correct. Okay. It's truly your atmospheric pressure around you. And that's one of the interesting things we have to take into account when we design with vacuum. If you're at sea level, this is where we have our highest amount of pressure, unless we start to go below sea level. But if you then need to do material handling at an elevation of 2,000 meters, this has a very different maximum pressure available. So your actual forces you can have available to you is reduced. So it's really this atmospheric pressure that's allowing you to do the handling.
Yeah, I've never even thought of it that way before. But now I'm going to make a note to myself to start my own science lectures series now that I understand that aspect of it. Well, great. So we reached a point in our show where we need to take just a short break and provide some information to our listeners about other opportunities in the fluid power industry. But we'll be back right after this to continue our discussion with Justin Katz. All right, we're back from our break, and I'm talking with Justin Katz of Schmalz, and we're talking about vacuum technology in digitized factories, or digital factories, I guess. And you just gave us a great overview of, I guess, how the vacuum technology works and how versatile it is. As we talk about this, I'm realizing it may be helpful for you to give us a description of how the compressed air actually creates the vacuum. That might be a good place to start.
Sure. So one of the main types of vacuum generation in the market is pneumatic vacuum generation, which does absolutely require compressed air to function. These types of generators are commonly known as ejectors. Another name for them is venturis. The name venturi is coming from the venturi effect that takes the compressed air and it forces it through a narrowing flow channel or a nozzle. And this causes a dynamic air pressure to increase and the static air pressure to decrease. And this is where we really get our vacuum draw. So this is how it's actually working. This is the most well-known concept that is out in the market, but it's only a few of the functioning principles or effects. There's another one called the Coanda effect, which is an air amplification concept. And then there's even another called the Bernoulli's principle, which is an air stream to create a suction force.
Yeah, the Bernoulli is the one I'm familiar with from an old aviation class I took when I was in college. That's what keeps planes in the air, right? It's the differential of flow over the airfoil, if I remember that right.
That's right. So the same effect where we have lift or this drawing upwards, we can leverage that as in a different type of generator solution to also create a pick and place or material handling gripper.
So are there any challenges associated with using compressed air in those ways? I mean, what makes that is that a challenging thing to do? What are some of the challenges?
Yeah, so the compressed air makes it a really versatile tool. It means that it can kind of go anywhere on the machine as long as you can get a compressed air line there. They're quite small in terms of their size, but there are certainly some inherent challenges. So, for example, a single stage Venturi, although it's very dirt tolerant because there's no moving parts, they do consume, a good bit of compressed air compared to their resultant vacuum flow that you get out of them, which is not the most efficient use. So because of this, there's a concept called the multi-stage Venturi, which uses the compressed air that, you're paying to compress and get to use. Right. We can actually use this multiple times. So what does it look like to not just use it once through one Venturi nozzle, but a second or a third? And so with this, we can actually yield quite a bit better performance depending on the application. So this improves the efficiency of the air and is really beneficial. So, that's one way. Another way is to say, well, how do we conserve compressed air? How do we use the air to do the job? But then once we reach a certain point, we hold. So we can actually integrate controls into the Venturi vacuum generator. So we can onboard a switch, we can monitor the vacuum level. And once we know we've reached a sufficient level that's safe for our process, we can actually turn this off, hold the vacuum with a check valve, and then continue to monitor that. And if the vacuum happens to go down due to a leakage, let's say, we can turn it back on momentarily, bring it back up, and then turn it off. This is also a really nice solution.
Yeah, it sounds like that's really one of the interfaces with the connected or digital factory concept, right? Where you're actually, those are sensors monitoring that in real time, it sounds like?
That's right. And so, we can do this at two levels. So this is, as you can imagine, completely controlled within the device. So this one doesn't have to have that data output necessarily. It's doing it within the device's controller. But then, yes, if we get into the idea that we then want to take this process data and output it as well to then process some other function, such as energy monitoring or condition monitoring, we can also do that with that same data being used on board.
Yeah, and I'm going to guess that those are really the cutting edge improvements that are being made on this technology, the ability to harvest and use that data in a way that adds either efficiency or productivity to the system.
That's right.
So what other advances are we seeing in that space?
So we are seeing, a number of things where we are really onboarding sensors to output this data, and we can integrate it and start to build a bridge between efficient product and efficient process. So if we take that data and we use this to leverage, as I mentioned before, some energy monitoring or condition monitoring, and then even predictive maintenance, these are all things that are really powerful to the production environment. So energy monitoring, what if we could look at the incoming compressed air, get a real value for that line pressure, and then also output that over time through a trend analysis. So then we can start to monitor per production cycle or per shift. So this is the idea of energy monitoring, for example. Condition monitoring, condition monitoring is more having to do not so much with the pressure side, but then the actual vacuum side. So what if we can measure the condition of that vacuum? How airtight is our system during operation? If a leakage happens, what does it look like to display this on the actual unit where an operator walking by can say, hey, this unit is having an issue. It's not failing at this point, but I know it may be coming soon. So you can see it on the unit and then also have it come back to the HMI.
This must be adding so much more benefit, to the factory owners and the factory managers, if you will, to be able to have this kind of capability now in their system. I mean, how would you describe the main benefits of implementing systems like this?
It's really understanding and knowing what is going to happen with your system, almost before it happens. This has a huge impact on mitigating, or I won't say eliminating, but really mitigating or lessening downtime. By doing a predictive maintenance cycle on your time schedule rather than a down situation, you're really able to make sure that machine is up and running at peak performance. So that just really has a direct translation to your bottom line production for the owners, for the managers, for the plant managers, for example.
I can imagine. Yeah, it must be a huge advantage. I mean, nobody likes a machine that goes down unexpectedly. So you got to schedule that maintenance, and this gives you the ability to do that.
Yeah, absolutely. It's a really unique thing to think about. To do all of these things when they actually need to be done. It's one thing to do a preventative maintenance schedule based on your timeline or just a set amount of time, but depending on how much you may run in a given week or month, that may change. And so now you can make sure you're not only doing things when they need to be done, but you're also not doing them too early, for example, as well.
Is this, Justin, I'm curious, is this the kind of thing that, you have to buy a new machine from the factory with these capabilities on it, or does this get retrofitted onto old machines as well?
So you can actually take this, one of our devices. So for example, we again have this standalone vacuum switch. It's not integrated into any type of generator. And you could actually bring this into any existing machine and start to realize some of the industry 4.0 benefits, very quickly. So as long as you get this integrated into the right position and you start to have the ability to interpret this data, then you, even in an existing machine, the user can actually realize that pretty quickly.
It sounds like, whether it's better production or less downtime, at the end of the day, we're reducing costs, for the manufacturer of whatever the product is that's being either moved or picked or placed or assembled or whatever the machine is doing. Do you have any sense of scale on that, or what are the cost benefits for the manufacturer?
So, we could look at, I think each manufacturer is going to look at their downtime, to say, what is that costing me? So, again, I go back to the automotive industry because this is where a lot of Schmalz's roots are, and we have a very strong tie to the automotive industry. Every minute they're down is thousands of dollars. And so if we can prevent that by integrating, a reliability check or understanding the quality of our vacuum and making sure that we are outputting that and we're not losing parts or maintaining the filtration system, whatever it may be, this has a real big bottom line value to them. So it's just, looking at each individual application, understanding the benefits for them and making sure that we work with them to get those implemented.
That's great. Yeah, as we wrap up here, Justin, I always like to turn towards the future. What do you think the next generation of technology is in this space, either the automation or digitization of pneumatics? What are some of the new technologies that you'd like to see come into the space?
I think you're going to see not just the communication of the devices. I also think you're going to see the digitization of a lot of methodologies to interact with the product. So, we look at this from a small scale to a large scale. So from a very simple scale or small scale, what does it look like to interact with that device to use it, to increase its usability? So for example, if we go back to the idea of this near field communication, this NFC, which is a wireless communication, it's kind of similar to your wireless payment systems that you have on your smartphone or your credit cards. If I could come up to that device, look at it, and I could say, here's how I can parameterize it. Here's how I can interface with it now on my smartphone. That's one form of digitization that I think is really beneficial, because you can start to use that in a much more user-friendly way, right, to really get a holistic view of how that device is operating. It also allows you to access, user manuals and documents very quickly and easily. So that's, at a very simple level where we can see digitization being used. And then moving on to, the more traditional sense of process monitoring and energy monitoring and things like that. So it really kind of spans, the ways that you can do this.
It sounds like there's a lot of opportunity remaining in this space to really leverage these tools that are now available through digitization or connectivity in new and creative ways. And would you agree that we're kind of at the beginning, not the end of that process?
Absolutely. I mean, we're going to continue to see this grow. I mean, we've kind of focused primarily on vacuum here, but many traditional pneumatic systems, which were considered dumb in the past, especially in comparison to their electric counterparts, I see them undergoing kind of a digital renaissance. And this isn't to say that there's not going to be some bumps along the way. We at Schmalz see this as the future, and we've already had a solution for this since about 2012. Me personally, I see digitization in the pneumatics market growing slowly but steadily. It's a marathon. It's not a sprint. Mm-hmm. If I take my experience as an indication, we've seen some challenges convincing customers to adopt this technology. But trying to convince them to go from a tried and tested, low cost, basic solution to an intelligent one, this really requires a higher initial cost and integration effort, but it's worth it. It's a conversation worth having.
Yeah.
So that's something we really want to do more and more. And as people integrate automation and digitization into their daily life, whether it's a smart thermostat or a self-driving capability in their car, they're really looking for this, I think, in their work life. And the companies that are prepared to address that are going to really be the winners.
That's great. Yeah, it's a revolution or an evolution that's certainly upon us, and we look forward to learning more and more about these advances. I know you'll be presenting, as we said, more and more of this information at the quarterly conference that we've scheduled, and I want to thank you and look forward to your participation there.
Well, thank you, Eric. Appreciate you having me.
All right. Well, that's going to wrap things up for this episode of Fluid Power Forum. My thanks again to Justin Katz of Schmalz, who has been my guest on this episode. If you want to connect with him directly, the best way to do that is by email, and we will be sure to put a link to his email address in the show notes. I know he would welcome your outreach and your attempt to learn more about the topics that he's discussed. You can also attend that event, the quarterly conference that I mentioned that Justin will be presenting at. Go to our hub at nfpahuv.com, and you'll get all the information you need about that event. Remember, if you like our podcast, please follow us on Twitter. You can find us there at the NFPA, and make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics we should be addressing on our show. Also, to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPI, the International Fluid Power Exposition. Our next show will be March 14th through the 18th in 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are produced by Maddie Parise, NFPA's Communications Manager, and I'm your host, Eric Lanke, reminding you to join us next time in the forum.